Hello friends, we are seeing applications of Sylow's theorem. In this video, I wanted to talk about PQR group. Instead of that, I will give you the idea through 56. So it is advisable you to work with the same kind of counting technique for PQR. Okay, let's see. Sorry for the outer noise, I cannot control now. I wanted to use mic, but now it's not available. I cannot go outside, so please bear with me. Okay, let's go for 56. Okay, let's see group of order 56. 56 I can write like 8 into 7, that is like 2 cube into 7. Always you write like that, write like this. Okay, from small to above powers also right here, huh? Now I wanted to do the Sylow's theorem. As I said, we will start from the third Sylow's theorem. First theorem existence, that is fairly okay, but let's start with the third one. N2 congruent to 1 mod 2, where N2 denotes the number of 2 Sylow, N7 congruent denotes number of 7 Sylow. Okay, N2 congruent to 1 mod 2, N2 divides this 7. Similarly, N3 congruent to 1 mod 3, N3 not N3, N7 divides this 2 cube. Here 1 or 7, here 1 or 2 or 4 or 8. 1 2 2 square 2 cube. Yeah, fine. Now let's see, the 1 is always possible according to this thing. 7 is also possible. Here 1 is possible, 2 is not possible, 4 is not possible, because 4 minus 1 not divisible by 7, 2 minus 1 also not divisible by 7, but 8 minus 1 can be. So we have a situation like this. N2 is 1 or 7 possible, N7 is 1 or 8 possible. We got 1 is okay, right? 1 7 is also okay, 1 8 also okay. 7 it is not okay, because in 1 1 N2 and N7 1 we get both unique subgroups. So that says that is simple. The question is that order 56 is not simple. Okay, in the last video also I supposed to mention that we wanted to get a proper subgroup to say not simple, and here also I wanted to mention not simple. Any other PQ is not simple. Okay, so I wanted to say this is not simple. I have to give a proper subgroup which is not trivial, not full, and unique implies not trivial, not full here, because it's order 8, it is order 7. So we are done. 1 and 8 is also fine, because we are getting unique Sylow subgroup here. 1 here, 7 here is also fine, because we are getting unique subgroup here. So in the 3 cases we are fine. But when N2 equal to 7, N7 equal to 8, we are suffering. And I am saying that climb such thing never happens. How? Okay, this is how. Suppose, assume that such things happens, then we will start counting, because both are prime groups. This is very important. Both numbers are the 2 and the 7, and the 7 is very very important. That is prime, and I wanted to count from there. Okay, let's list down this 8. Let's list down this 8 like this: K1, K2, K3, K4, K5, K6, K7, K8. I will count identity plus remaining how many elements? I have 6 elements, because order is 7. Then another 6 element will come from, because Ki intersection Kj is trivial when I not equal to j, because both are prime subgroup. If it is a non-trivial intersection, then that must coincide. Okay, so anyway, because because of that this will give 7, this will give 6, this will give 7, but I already counted the identity. This will give 6, 6, 6, 6, 6, 6 because of the same factor 6. So totally I have 1 plus 8 times 6, it's 49. Now remember that I have a 2 this thing. I have a 2 let's say H1 and H2, 2 Sylow, at least 2 Sylow I will get, because 7 I will get anyway, I will get 2 Sylow. Then I will count from here. Already identity counted, then fine. Then this will give me 7 elements. How? Because order of this is 8, order of this is 8, and I already counted 1, and all the things are divisible by, the order is 2 powers, so this will give a 7. So 49 plus 7 is 56. But this is there, right? This has to give at least 1, because H1 is not equal to H2. This has to give at least 1 to this sum, so 57, but which is not possible because we started with order 56. So hence we started with the order 56. This is not possible. So this case is completely false. It is not possible, and only these 3 cases will happen, and hence the proof. This is not simple, because I proved at least one of the Sylow subgroup is normal. Okay, next video I will prove about the 96. But the same idea you can use for PQR, and P comma Q comma R are primes, and P less than Q less than R you can use. I will prove about PQ in the next or some other lectures, because which is needed, and also order 12 I will talk about. But you try to prove the same counting idea, it will exist if you assume that not all of them are unique. Everything is not unique, then you will get some over counting. The same idea you can do it. Okay.